Okay, definitely the hardest part of what we did so far with logic statements is deciding if conjectures are false and providing counterexamples. Can't give you really an easy way to do this because you are actually trying to go against maybe what is normally thought of and try to prove a maybe seemingly true statement false by finding the few or the one counterexample that may exist. Okay, the good news is that you only need, recall, you only need one counterexample to actually show that a conditional or statement is false. We also need to recall that we have to make the hypothesis true and then show that the conclusion does not follow from it. I notice that a lot of times people like to give just random examples where the conclusion is not true. But if the hypothesis is not true, then it doesn't matter whether the conclusion follows. You're just giving me a non-example. Let's work through a couple of these harder ones and see if we can either draw a picture or come up with some kind of counterexample. First one, if point G is on AB, I'm finding the hypothesis of that statement. Point G is on ray AB, that has to be true. So I'm going to go ahead and draw a ray. Okay, there's ray AB. And I need to put point G somewhere on that. So G could be, right, the ray keeps going, but I'm going to go ahead and put G somewhere between A and B. Then I know for sure it's on the ray. Okay, I've made my hypothesis true. Now let's see if the conclusion follows. The conclusion in this one reads G is on ray BA. I can't move point G. Point G is already on there, but I can look at it and say, G, is that on ray BA? So ray BA, recall ray starts at an endpoint and goes through the other point mentioned and keeps going infinitely. So ray BA in my example is going to the left. Is point G on ray BA? And hopefully that you are agreeing with me that yes, in my picture it is. So what I actually did is I came up with an example where the hypothesis is true and the conclusion is true. Have I provided a counterexample? Absolutely not. Have I proved the statement true? Absolutely not, because it's only true if I can't give a counterexample, and I'm not going to give up after one attempt. I'm tougher than that. So I'm going to go back, I'm going to relook at my example, and I'm going to say, could I have kept the hypothesis as true by putting point G anywhere else? Point G has to be on ray AB. That's the blue ray. So point G can't go on the other side of A, but point G could go on the other side of B. And if I move point G down there, still on ray AB, so hypothesis is still true. Let's see if the conclusion follows. Is G on ray BA? And recall a ray only goes infinitely one direction. In this case, it starts at B and it goes infinitely to the left through point A and keeps going. But is G on that ray? No, G isn't. G is on the other side of B. Therefore, I have effectively come up with an example where my hypothesis is true, the conclusion does not follow, G is not on ray BA, and that would be my counterexample. So sometimes you can just draw a counterexample, and that's the best way to show it. Let's try another one. Now we're going to work with some numbers and a little bit of algebra. If AB is less than 0, then A is less than 0. Okay, what I'm really saying in the hypothesis with my letters and symbols there is that the product of two numbers, A times B, has to be less than 0. Think about that. You're multiplying two numbers, they have to be less than 0. Well, we know positive times a positive certainly isn't going to give us a negative number less than 0. And a negative times a negative gives us a positive, so that's not going to give us a number less than 0. So I'm at least going to narrow it down to that in order to make my hypothesis true, I'm going to have to use one positive and one negative number. So just to get my negative out of the way, I'm going to say that A is negative, let's make it -2, and B is a positive 3. I'm just picking two numbers there, and I'm going to test it out. Okay? If I pick A is -2 and B is 3, does it work out that A times B is less than 0? Well, let's see. A was -2. B was 3. I'm going to plug in those and see if that is less than 0. I've got kind of a question mark over this. Negative 2 times 3 is a negative 6. Is that less than 0? Indeed, it is. So I have effectively come up with a set of numbers in such that the hypothesis is true. I'm going to put a check right there, or you could make a little note. Hypothesis true. Does the conclusion follow? Conclusion in this case is A is less than 0. So let's go back to my numbers, and I need to show somehow that A is less than 0. My A was negative 2. So negative 2 is less than 0. And in fact, negative 2 is less than 0. It's a negative number. So I actually showed right back to where I was with Ray BA and G being on BA. I showed the hypothesis true and the conclusion true, but that's not what I wanted. I want a counterexample. To get a counterexample, I have to show that the hypothesis is true and the conclusion is false. So, how can could we come up with a different counterexample? Remember what we said about the hypothesis. We have to have a negative and a positive number. I'm going to sort of try to maybe save myself a little time there. Could I actually just switch those and make A 3 and B negative 2? Of course, I can pick any numbers I want. Notice that I'm switching B to being negative. Let's see what happens. A times B is less than 0. Well, technically, the order of multiplying really doesn't matter. So I don't know that I need to rewrite this, but just for the sake of showing my work a little more clearly, I'll put A times B, still getting negative 6 less than 0. Hypothesis true. I didn't change the hypothesis other than switching the numbers, but multiplying order doesn't matter. When I get to my conclusion, my A is no longer negative 2. Now my A is 3. So I'm going to put a 3 in there for my A. Is 3 less than 0? That's my question. 3 less than 0. No, 3 is not less than 0. 3 is a positive number, so 3 is certainly bigger than 0, and therefore my conclusion is false. Sometimes we show that just by putting a line through it. 3 is not less than 0. And if I have shown that my hypothesis is true, my conclusion is false, I now have a counterexample. So essentially, my counterexample is A equals 3 and B equals negative 2. And I like to say because, you can either say in words, because the hypothesis is true and the conclusion is false, or you can say because, I've got it all set up here very nicely, negative 6 is less than 0, but 3 is not less than 0. Whoops. 3 is not less than 0. Hypothesis true. Conclusion false. And now I have a pretty nice statement really to support my answer of what my counterexample is. Okay, a lot more reasoning than actually writing here. Last one. If angle 1 is complementary to angle 2 and angle 1 is complementary to angle 3, then angle 2 is equal to angle 3. Might as well end with a geometry one. I'm going to draw a picture because I have no idea what I just read. I'm not going to make my angles adjacent. I could make my angles adjacent, but in this case I've got 3 angles and I don't even know how to draw 3 adjacent angles that are complementary. So I'm just going to give myself a few angles and put some numbers with them. And then let's see, I had a third angle there, except I think we're talking complementary. So I think we're pretty safe on saying that these have to be acute angles. Angle 1 is complementary to angle 2. So I need some numbers. Complementary adds up to 90 degrees. I'm going to go with 40 degrees for angle 1, 50 degrees for angle 2. 40 plus 50 equals 90? Okay, good. I satisfied the first part. Be careful when you read this one. This is a rather long conditional statement, and my hypothesis actually keeps going until my then, which is not till the second line. So I've only made half of my hypothesis true. Angle 1 is complementary to angle 2. That's what I have done right here. Okay, moving on, let's go ahead and look at the second part of this. Angle 1 is complementary to angle 3. I already picked 40 degrees for angle 1. What does angle 3 have to be so it's complementary to angle 1? So maybe you're doing something like this. 90 minus 40 is what I'm doing. I'm getting 50 degrees for angle 3. Now 1 plus 3, 40 plus 50 is equaling 90, and I've got complementary. I think I can now say that my hypothesis is true. Does the conclusion follow? Conclusion states that angle 2 is equal to angle 3. So I'm going to find angle 2 and angle 3. Angle 2 and 3, there they are. And in this case, both of mine were 50 degrees. Did I come up with a counterexample? Nope. I came up with a good example of showing it true, but one example is not enough to show it true. So how am I going to show it true? The only way, as of right now, that you have of showing something true is to not be able to come up with a counterexample. So I should probably, at this point, do another example. The last two, it took me 2 examples to get my counterexample. So I would redo this. I would start with a different angle, pick a different number besides 40 degrees. Go ahead. I recommend that you try that one right now. At some point, you might kind of come to terms with this, and I'm going to sort of just talk you through this. If you think about it, angle 1 complementary to angle 2, it really doesn't matter what I start with here. I'm going to end up with an angle that's making it equal 90 degrees, but at the same time, because I'm given angle 3 is complementary to angle 1, angle 3 and 2 both have to make the same angle equal 90 degrees. So the math tells us they're going to have to be equal to each other. And when you come to sort of that conclusion, you're pretty good to say that this one is actually a true conditional. And for those of you that aren't quite satisfied, that's okay. I'm not quite satisfied either. But luckily for us, geometry does give us a way to, and logic gives us a way to actually prove statements are true. And that's where our friend deductive reasoning comes into play. When we get to deductive reasoning, we can use properties that we know to be true. We can write a series of statements that we can justify by known facts, properties, known statements, and we can actually show for any general example, not just a 50-degree angle or a 40-degree angle or a 32-degree angle or whatever angle you picked, we can show that this statement will always be true. So that's where we're headed, folks. Next week, we will come back to this exact same statement, and we will prove it true. Right now, you're not really proving it true. You're accepting that it's true because you can't provide a counterexample. So that's kind of what you're resorting to. Usually that's not enough for us, and that's where we come to deductive reasoning. Keep this one in mind. We're coming back to this question, and this will be a good